All right, today we're moving on with chemistry, getting a little more in depth. Today we're talking about bonding. Bonding is a really important issue with chemistry because this is how energy is formed. And again, we mentioned yesterday that energy is important because that is what our body is doing. It's trying to make energy, it's trying to save energy. It's what all organisms want to do. So bonding involves the interaction between the electrons and the outer valence shell. So the outermost shell, the electrons spin around the protons and the neutrons that are in the center, and there are different electrons in different shells. And if a shell gets full, oops, sorry, I didn't mean to hit that. If a shell gets full, then the electrons go to the next shell, and it kind of keeps going on like that. So the atoms like to have full shells of electrons. If they're not full, then they're not exactly happy. And so they will try and do things to make their outer shell full. And that's how these bonds are going to occur, is they're trying to fill their outer shells. Each shell can hold a certain number of electrons, and it depends on like which shell it is. So let me draw it out. Maybe that'll help it make a little more sense. So we have our protons and our neutrons, and then we have our first shell, which I remember correctly holds 2 electrons. And then the next one, I think, holds 4. So if we have 2 electrons, that fills up this shell, and then it'll start filling up this one, then it'll go to the next one until each one gets full. So valence shells are not full, that are not full are unstable, and so it wants them to be full. So here's our first one. Actually, I guess the second one holds 8. I was wrong. And then it bumps it to the next one. So if it's not completely filled, then it's not happy. Remember, this whole homeostasis balance thing. Yes?
I don't think we're in the process just so that I can get for can I just have
Yes.
jump it side out?
No, you just
Yeah.
So we have to make sure that the outermost is filled. So like our sodium atom over here, here's sodium. It only has 1 out here in this shell because we're paying attention to the one that's on the outermost edge. That means it is not happy because it can fit more and it doesn't have all the ones that it needs. So what happens is it will try and fill that outer ring by other methods. It will either give the electron away or share electrons with other atoms in order to try and fill that outer portion. And that's how the bonds are formed. So here's hydrogen. Hydrogen only has 1 electron, but he can hold 2. So he wants to get another electron somehow in that ring. Carbon is really unique because carbon can actually form 4 bonds because his outer shell can hold 4 more. So he can fit 4 more electrons, which means he can form a couple extra bonds there. Alright, so the first type of bond is the ionic bond. There are ionic and covalent bonds and also something called hydrogen bonds, and those are the ones we're going to talk about. Ionic bonds form when electrons are completely transferred from one atom to another. So basically what happens is it gives its electron away. It completely gives it away to another atom, and now that electron is missing. So what happens when they do that, though, is, remember, electrons are negative. If it's giving an electron away, then the atom is going to be partially positive because it's no longer balanced out. So it's now got a partially positive charge. And the atom that it gave it to, because it took the extra electron, now the other atom is partially negative. So what happens when you played with magnets in elementary school and you put a north and a north pole together? It repels. What happens if you put a north and a south pole together? It attracts. So positive and negative forces attract. So if one atom is positive and the other atom is negative, then they're going to be attracted, kind of like magnets are attracted with the opposites. So that's what we see happen with an ionic bond. It gives its electron away. Because it gave the electron away, now it's partially positive. The one that took the electron is partially negative. And so the negative and the positive are going to attract. Anions and cations are what it's called. For anions are the negative ones, cations are the positive ones. All right, so this is in Google Classroom for you, so you don't have to write all this down, but it's kind of summarizing the process. So remember, anytime you see that star, you've got this slide. Elements like to be balanced. They like to have the same number of protons and electrons. Protons positive, electrons negative. Elements also like to have a full valence shell. Sometimes they can't have it both ways. So if they give the electron away, now one of them is slightly negative and one of them is slightly positive. And that positive and negative are going to attract. So that's what an ionic bond is. A great example of this is sodium chloride. Does anybody know what sodium chloride is? Salt. Sodium chloride is salt. So sodium has this extra electron in its outer shell. Remember, we just are paying attention to the outer shell. And it doesn't want that extra one because it wants to be balanced. So it gives the extra one to chloride, who needs an extra one to fill up his shell. Well, it gave it away, so now it's slightly positive because the electron's negative. Now the sodium is slightly positive. The chloride took it, and now it's got a little bit of a negative charge. So the positive and the negative charge are going to attract. And this picture is also in Google Classroom for you. All right, now covalent bonds are a little bit different. With covalent bonds, they are sharing electrons. Nobody is giving it away, they're just sharing it. The way I kind of compare this one is, let's say you're holding hands with somebody. You're not cutting off your hand and giving it to them. You still have possession of your hand. You're just sharing your hand. And between sharing your hands, you guys have made a bond between the two of you. That bond can be broken. The hands can come apart. But there are two hands involved in holding hands. There are two electrons involved in a covalent bond. They are keeping their electron. They're just sharing it with the other atom. So there are typically two that are involved with a covalent bond, and they're sharing them. They're not completely giving them away. In ionic bonds, they give them away. In covalent bonds, they are sharing. Sometimes the bond can be extra strong. So if you are, if the bond needs to be extra strong, then they will share 4 electrons instead, 2 from each one. And that's called a double covalent bond. I know they can do triple bonds, which are really, really strong and very difficult to break. I don't know if they can do quadruple or 4 bonds. But there are triple covalent bonds that are possible. So the more bonds, the stronger it is. So here's some examples. The best example is water. H2O is an example of the covalent bond. The hydrogens only have 1 electron, so they want another. But they don't give up their electron entirely. They'll share it. So here are 2 hydrogen atoms, and they can join together, and this is what an H2 example would look like. So 2 hydrogens together. Here's some oxygen. They have space for 2 more electrons to fill it up, so they can share, and then they can make, here's a double bond here, 1 bond, 2 bonds, And so they've made a double bond. Anytime you see two lines, that represents a double bond or a covalent bond. Anytime you see one line, that represents a single covalent bond. So here's an example I like to use to imagine how the bond process works. The bond stores energy. What would happen if you let go of her? She'd fall. So right now they have potential energy, right?
Yeah.
When the bond breaks, it's kinetic energy. That's how this works. When the bonds are broken between two atoms in some kind of molecule, when the bond is broken, that's when the energy is going to be released. When you want to store energy for later, you have a bond being formed. That's what our body is doing every time it makes energy. It breaks bonds to release energy. It forms bonds to store energy. Now, to be more safe, don't ever do this, first of all, but to be more safe, do you think the bond is going to be stronger if they're holding both hands or just one hand? Both hands. Be even better if they got a third person in there with more hands to help hold on to her. So the more bonds that are present, the stronger the bond is going to be, and the harder it's going to be to break that bond. Don't do this. Don't hang off a cliff. Bad idea. All right. Now there's another. Is there any questions between covalent and ionic before we move on? Okay. I'm hoping this is reviewed to some extent. Polarity is a little bit different. With polarity, what we see happening is that they're still sharing. Like in a covalent bond, they're still sharing. It's just one of them is a little more greedy, and one of them holds on to that electron a little bit tighter. So like in that picture we saw, imagine that the guy was holding on a lot tighter than the girl was. And if that's the case in a covalent bond, then you might end up with a slightly positive and a slightly negative charge. So here we see water. This is H2O. So we have two hydrogens and we have an oxygen. The oxygen is a lot bigger. So it grabs on to those electrons a lot stronger. So that means the oxygen is going to be just slightly negative, a slightly negative charge. And because those hydrogens are smaller, they can't hang on as much as they want to their electrons. So they're just going to be a little bit positive. Now this is really unique with water because it's still water, it's still H2O, but it's slightly positive and it's slightly negative. Because of that, water can do a lot of really cool things. Water is the universal solvent where it dissolves a lot of stuff because of this polarity, this slightly positive, this slightly negative. Water also groups together. This is responsible for surface tension. Did you ever do the drops on a penny thing in elementary school? Yeah? The reason you can fit so many drops of water on there is because the water is holding itself together. And that's because it has a slightly positive and a slightly negative charge. So water is a little bit special. It's not the only one that can do this, but it is one of the best examples. And it's responsible for a lot of things, like how the water gets from the roots up to the leaves of a plant. It's because the water is attracted to each other by these polar bonds. These polar bonds are special because they're easy to break, but if you put a bunch of them together, it makes it really, really strong. This is actually called a hydrogen bond. So here you can see what the hydrogen bonds looks like. Here's our oxygen and our two hydrogens. Here's our oxygen and two hydrogen. The oxygen's being greedy, holding on to that electron extra tight, making it slightly negative. The hydrogens, they can't hold on quite as much, so they're a little bit positive. So the positive and the negative get attracted by this hydrogen bond. Now hydrogen bonds are not like covalent and ionic bonds. They don't form something different. It's still water, but it makes the water kind of stick together. It's also really easy to break. We're going to see bonds like this appear in the body at different times when we want things to stick together, but we want them to break apart. For instance, our DNA. This forms the central line of our DNA because our DNA needs to constantly split apart so we can make copies of it and then join back together. So these hydrogen bonds are responsible for that. They also help give the twisted shape, that double helix shape, to our DNA. With other types of bonds, ionic and covalent, it can from liquid to gas or to solid. With hydrogen bonds, it's still the same element, it's still the same property, it's just now easier for it to stick together, it's easier for it to break apart. Think of it also as like a single piece of thread. If you have one piece of thread, you can snap it in two. But if you braid a lot of those threads together, it's going to be a lot stronger. And so that's how it is with hydrogen bonds. One individual hydrogen bond isn't very strong. But you put a lot of them together, it's going to make it a lot stronger and a lot more difficult to break. Alright, so that's all we're covering today. Ionic versus covalent bonds. You will need to be able to give examples of each and explain how it works. So the best example of an ionic bond is sodium chloride or salt. The best example of a covalent bond is water, although there are many other examples of both of them. Understand hydrogen bonds as well and why they are important and how they are formed. That they are not a true chemical bond because it's not changing the material itself. It's just making it so that it sticks together a little bit more. Any questions about any of this? Okay, is this at least a little bit familiar? Okay, good, good. All right, so I think most of you got a good start on the crash course yesterday, and a lot of you, I think, probably even finished it. So focus on the crash course first. The next thing you're going to do is Chapter 2 vocabulary. So there's a list of vocabulary terms in Google Classroom. For this, you're not making flashcards. You're just finding the definition and then writing the definition in your own words. So I don't want you to copy the definition word for word from the internet or from a textbook or whatever. I want you to find the definition and then try and put it into your own words so it's a little bit easier to understand. So there's a list of terms in Google Classroom, and then for each one of those, you need to write a definition for them. So that's your new assignment. Both the crash course and the vocabulary are going to be due on Friday. Any questions? All right, go ahead and get started. And I was working on your test for this new unit. What it's going to look like is we're going to kind of put chemistry, parts of the cell, and mitosis. We're going to put it all together. So it is going to be a little bit of a bigger test, but since it's all kind of review, hopefully it won't be too hard. It's not like I'm teaching you anything brand new here. Hopefully this is just kind of review of stuff you've already learned. So.